Hello everyone. Happy Sunday. Hope you've had a great weekend so far. Um, I'll quickly go through the slides for week 2 for some people who missed the class, and also it's a kind of a quick review for ggplot and visualization in R. I will go through a different data set and show you some plots in ggplot, and then at the end I'll go through the lab works for week 2 to make sure that they're clear. And still, if you have any questions, please send me an email anytime you want. One of the students after our last session on Thursday suggested, to post these videos before the weekend so that everyone has enough time, during the weekend to uh, watch the videos. That's a very good suggestion, and I really appreciate it. I'll definitely do that from next time. Right now, I really couldn't do it on Saturday, but today I'll try to post it as soon as possible after I finish uploading this video. And all right, let's start with visualization in R, ggplot, and I'm just gonna open a new tab of RStudio, and let's get into ggplot. Now, the first step was we talked about this a few times, but still some people had a question after the class on Thursday night, which, because we're using this library called ggplot2, the first time you need to install it, and then you need to load it every time you want to use it. So for example, if you don't have this package on your laptop, you go to Packages tab here, Install, and then type ggplot2 and install, and it will start downloading the package itself automatically and install it on your R. There's not many libraries we need for this quarter. There's just like ggplot2 is the main one, and there's also another package called caret package, which we will see for applying predictions and classification tasks, hopefully next time. All right, so that's the first step, and just make sure that anytime you want to use the library of ggplot or any other libraries, if you want to use them, you need to load them. I'm first going to create an R script here, an editor. We're going to do a quick review of ggplot. Now the first step is to load the library ggplot2, and afterwards we can use all of the functions that are in ggplot2. For example, all of the the box plots, the scatter plots, all different kind of plots that are implemented in ggplot2. I'm gonna create a new folder, a new file, week 2, just to put in the examples. Now here, during the class we went through this MPG data set. Now I'm just going to use a different data set, the empty cars, which you probably saw before. I can create a new variable, a new data frame called the same empty cars, and load empty cars inside this variable so that we get it, we get this data frame inside this environment tab, and we can click on it and see all of the fields in empty cars. See how it looks like. All right, I'm going to run this line of code and then empty cars, and here we go. We have this data frame which has 32 objects and 11 variables, 32 rows, 11 columns. If you click on empty cars, you get the data set. Now, this is the data that we want to use right now for ggplot instead of MPG. This is what we did during the class, and all of the codes available in the other slides, and the rest of the slides are using the MPG data set. We want to use the empty cars instead. Here we have all of these cars and the row names, as you can see, all of these car models. And here we have these column names, remember, call names of the data frame. And you can probably guess from each of the headers what they are. This is the MPG, the number of cylinders, display, horsepower, and so forth. This is weight. We will be using this. This is q-sec. It stands for I think a quarter mile second. Like how many seconds does it take for the car to drive a quarter mile? I think so. I mean, I think that's what it means. And some other variables which we're not probably going to use right now. The number of gears and so forth. Let's quickly start with a simple ggplot and to visualize some of the variables here. Now, the first thing we talked about in ggplot 2 was a histogram. So the definition of a histogram is counting the frequency of every variable in a bin. For example, if you have this data here and the bin width is 1, so it means like in intervals of length 1, how many of these numbers do you have? And then you can just plot it and it will show you the distribution. It's a sample like distribution of that data. There's plenty of resources available on the web about histograms if you want to get into more details, but this is generally how it looks like. So we use a histogram to visualize only one variable. That's the main point. It's only one variable because we want to look into the distribution of one variable. Let's do a very simple example here. Let's look at the MPGs here, for example, and let's draw a histogram of MPGs and see what the distributions, what is the distribution of MPGs among these cars. I'm going to go back to my code here. Now I will start with ggplot. Now ggplot is the body of the function every time we want to use it. Any sort of visualization you want to do in the ggplot2 library, we start with the ggplot function and we put in the name of our data set or the data frame that we have, and we use AES to show or to input the variable that we want to plot. For example, in this example, we want to see the distribution of MPG, and this is the column name MPG, right? Now here in AES, I will put, you can either put x equal to MPG, which is the name of the column name. Just want to make sure that you don't think this is the data frame. This is not the data set MPG. It's the column name, the first column name in empty cars. See, it's called MPG. Here it is. So here again, we put the name of the data set that we're using, and then AES. This is just syntax, and then the name of the variable or variables that we want to plot. In this case, we only have one variable, so we're going to put x equal to MPG, and that's it. And then you can also remove x equal to. I mean, it doesn't matter. You can do both. It's, I mean, as by default, this is x equal to MPG. Now, this is the body of the function. So if I run this line of code, see what happens. If I run this line of code, nothing happens, right? I mean, you just see like a plain plot here under the plots tab, and there's nothing here. Now, this ggplot body function is only for initializing or initiating a plot in ggplot. That's it. Now, afterwards, we have to tell ggplot, okay, which type of plot we want to see here. And this is, the next part is basically going to be the interface of ggplot. Okay, now we want to use a histogram, and the function for histogram is geom_histogram. Enter. And that's it. Let's see if this works. It does. I mean, you can see that it works, but and then you can click on zoom to see a larger view of your histogram. Now, the only warning we got here was that we didn't set the bin sizes, and the default is 30. That's what it's using. So the bin size was the, I mean, it's using like 30 bins, so it's not even the bin size. It's the number of bins that it's using. That's why you can see the resolution of our histogram is like very high. I mean, you have like so many of these bars. It's because the number of bins are very high. and it's dividing like the whole MPG values, set of values, into very small intervals, and counting like how many of those MPGs we have in each of those intervals. That's why we have so many bars here. Now here inside genome histogram, we can define the bin width. So this is the bin width. It's different from the number of bins. The bin width we can define as, for example, 5. Let's see how it looks like. I'm going to run this line of code, and here you can see a box plot, a histogram, which is using a bin of 5. So it means like from this point, which is, I don't know, like maybe 8, from MPG 8 to, for example, 13, because the bin width is 5. How many MPGs do we have in this range? And then you can see here we have probably 2. This is, I think it's probably 2. So we have 2 MPGs, 2 cars that have an MPG between 8 and 13. And then from 13 to 18, and then 18 to 23. So this is the bin width, right, basically. And in so for example, here in this range, which is, I think it's from 18 to 23, we have the highest number of MPGs. See, there's almost like 10, 11 cars, I don't know, 11 or 12 cars that have the MPG in this range. So easily by looking at this histogram, you can first of all look at the distribution of this histogram, how it is, and also figure out like which bin width, or which bin size width here has the highest number of MPGs. We can say that, okay, most of the cars, or not most of the cars, I mean a lot of the cars have a MPG between 18 and 23. That's probably the highest frequency in this range. Now you can just play around with this number. I mean, you can just put 10 and see what happens. See, we get a smoother histogram, as you can see. And now this is probably not going to show us the exact distribution. I mean, as you can see, it's like with a very low resolution, but it's a trade-off. I mean, there's no exact number for the bin width that you want to pick. I mean, for example, if you pick 1, look how it happens. See what happens. See, you get a lot of, bar plots. And again, this is not also a very nice representation of distribution. It's something between. I mean, it's just like a trade-off. You have to pick something else. I think 5 is good as well. It's good enough to show the overall distribution of this data. Anyway, now with genome histogram, I mean, you can play around with it, and the great thing about ggplot, as we talked, is we can easily add other features to the plot simply. For example, my plot is missing a title, right? We don't have a title here. We just want to explain it. I can add a function called ggtitle, and then put a string here and say this is my or let's say this is the distribution of MPG, for example. If I run this line of code, see what happens. I get this title. So this is something very cool about ggplot, that we can just add the features right after each other, and add more labels and features and anything you want to this plot, and you can customize it. I mean, that's something very cool about it. You can change almost anything on this plot. And something else is that you can put a plus again and then go, for example, to the next line. I can go to the next line. I mean, in R, anytime you have a plus or a comma, you can go to the next line, and the next line is going to be considered the continuing of the previous line. That's what happens. I mean, R understands that if you have a plus here and then you go to the next line also belongs to the previous line, to the first line. Now it's plus. Let's add some other features that we talked about on last week on Thursday, which was you can also set up these labels for the y-axis and the x-axis. Let's say I want to change this y-axis to so I can use y-lab. It's like the y label of the y-axis, and I can put something else. for example, numbers, or I don't know, or like count, or well, it is count. I mean, by default, that's what it is. But yeah, you can just put number. Just an example. I'm going to run this 2 line of code, and you can see this changed to number. You can do the same thing for x, so it's going to be plus x lab, and then you can put something else instead of mpg, mile per gallon, for example. And then run this line of code, and then you can see that, okay, here we get the xlim. So another feature you can add here is the limits of the x and y axis. For example, well, right now it's between 0 and, I mean, for the number here, it's 0 to, I don't know, like 12 or something, and the x-axis is from this number, which is, I don't know, like maybe 5 to like 40. We can easily change the limits by using a function called either xlim for the x-axis or ylim for the y-axis. Xlim of, and then you have to define the lower and the upper bound of the limits. Let's change the xlim from 0 to like 50. See what happens. Just look at the plot, see what happened. It narrowed down a little bit because we widened the range of the x-axis. That's the reason. You can do the same thing with the y-axis as well. All right, and then some other things you can add here is, for example, you can go into gem histogram and add some more features for the histogram. For example, if you want to change the color of the histogram itself. Anytime you want to add a new component to the whole plot, you're going to use a plus and then add that component or that feature to the plot. But if you want to change something, for example, about the histogram, like the color or I don't know, like the shape or anything, you just have to go inside gem histogram and change the color to, for example, red. Let's see what happens if we run this line of code. Here we go. This is like the edge color of the histogram, the bars in the histogram. It's just turned out to red. If you want to change the filling colors, which is gray right now in this histogram as default, you can change the fill feature to something else like green, and then run this 2 line of code, and it changes to green. All right, so that's how a histogram works, and it's a lot of time useful. Now I'm just going to put a comment here. So this is how we do a histogram, and I'm going to save this code. And yeah, so this is all the features we talked about, which you can set up. And then there's also another thing called density plot. It's like a smoothened version of a histogram. It's the same, it has the same use, which you can use to show the distribution of your data. The only difference is that instead of gem density, instead of gem histogram, we use gem density. Kind of quick go over it. I mean, you can do the same coding and reproduce the same plots if you like. The other one is a bar graph. If you have one variable, you can do this bar graph. We saw this during the class. I'm going to skip it. I'm going to get to scatter plots. So scatter plots are really important. So histogram, scatter plots, and box plots are the 3 main visualization tools used a lot. I mean, we use them almost everywhere. Now, so let's look into a scatter plot. What is it used for? Let's go back to our data in empty cars, and let's look into some of these variables. For example, well, next time on week 3, hopefully this upcoming Thursday, we will be talking about correlations and causation, and we will get into this concept in detail, and we will see how we can calculate the correlations and stuff like that. But just for now, we want to show some sort of correlation between 2 variables here and visualize it on a plot. For example, let's ask a simple question. Do you think there's any sort of correlation between the weight of the car and the q sec, which is the quarter mile per second that takes, I mean, the number of seconds that takes a car to drive in a quarter mile? Well, we have no idea. I mean, by looking at these 2 data, these 2 columns, we really can't say that if the weight is like high, if the weight gets higher, is the q-sec will get lower or get higher? We have no idea, really. I mean, by looking at this, I mean, in reality, the real data sets are not going to be this small. That's something really, I mean, important to know. In reality, data sets are way bigger sometimes. You know, we have like a couple thousand of rows a lot of times, and it's really not easy by just like looking at the numbers in a manual, in a manual fashion to figure out if they have any correlations or not. We have to do this kind of like analysis. But here, this data set is pretty small. It's just like for learning purposes. All right, let's look into WT and q-sec. Now, what I want to do is I want to do a plot, a two-dimensional plot, x and y. And on one dimension, I want to visualize, I want to show the weight of the car, and the other dimension, we want to show the q-sec. All right, now let's do this. So we want to show weight on one axis and then show q-sec on the other axis, a scatter plot. All right, again, because it's a ggplot, we start with this body of ggplot, which is ggplot, and then indicating the data set that you want to use, and then AES of showing the x and y of your plot. So on x, I want to show the weight, and then on y, I want to show the q-sec. Now, one more time, you can also remove the x equal or y equal here if you want, because by default, the first one is going to be considered, WT is going to be considered as the x-axis, and q-sec is going to be considered as the y-axis. And you can, I mean, simply remove x equal to if you want. But anyway, I'm just going to keep it there. All right, so I'm done with that. Now, if I run this line of code, what happens? Again, nothing. See, you get a just get a plain plot, plane here with no plots on it. And the next step, we have to define what kind of plot we want to visualize here. Well, in the previous one, we did a histogram. Now here, we want to do a scatter plot. I'm just going to put geom points. So it's just going to put like data points in a two-dimensional plot. Now, geom point, and that's it. It's that simple. Let's run this line of code and see what happens. As you can see, we get a ggplot here, which on the x-axis, we have the weight of the cars, and on the y-axis, we have the q-sec. Now, just by looking over this plot, well, we can simply see there's no really obvious correlation between the weight of the car and the q-sec, as you can see. I mean, but let's play around with this this scatter plot a little. Again, just as we did before, we can add a GG title. Okay, for example, let's say we're looking into the correlation of WT and q-sec, for example, and then plus you can, I mean, add any other features you want, just as we did before. I'm just going to skip this for now to save some time. If I run this, I get the title as well. So you can do the same thing in all different plots. I mean, you can just add plus the x limit, plus the y limit, plus the x lab, plus y lab, plus theme, text size, which we saw which you can find in the slides. Anyway, let's look into the geom point a little. I mean, if we open this plot, sometimes, okay, like when I look at this plot in the first glance, I don't like the size of the dots. I mean, I think they're too small. So I want to change their size. Now, so these sizes is the size of these data points are, or these dots are, a kind of like parameter of feature of geom underline point. That's why I go inside geom underline point and change the size of the data points. And here we go. We get some larger. If they're not still large enough, you can increase the size, for example, to 5, and then run the line of code. And then, all right, I like this one. It's pretty. Yeah, I mean, I think the size of the data points is pretty well. Now, how about, I don't like black. I want to change the colors. So I can, here, you can change the color to, let's say, I don't know, like blue. Also, don't forget to put the double quotes anywhere, because, because if you don't put the double quotes, the R I mean the compiler and R will think that, okay, blue is a kind of like variable that you have defined. So we put it inside double quotes to show that this is the string blue, the color blue. Let's run this line of code and see what happens. And here we go. We get this color. And then you can simply change the color to anything else you want, to green, gray, black, anything. And here we go. All right. Now, so I mean, we saw that, okay, there's no correlation between WT and the weight and QSEC. Do you think there's any kind of correlation between the weight of the car and MPG? I mean, maybe. We can test that out. See how simple it is. All right, I'm going to keep this as WT, the x-axis of my scatter plot, and I'm going to change Q to MPG. And let's run the same line of code. And here we go. We get a different plot, which on the x-axis, again, we have the weight of the car. On the y-axis, we have MPG. And you can see there's a kind of cool correlation between them. This means that when the car gets heavier, the MPG also goes down as well. So there's a negative correlation between the weight of the car and the MPG, right? And that makes sense, kind of. Like, I mean, when a car gets heavier, like a SUV or a truck, their MPG also should be lower than, you know, a compact size car. Now, something else is that in empty cars, if we look into the we also, I mean, have some other variables that we can look at. For example, the number of cylinders. Now, the maximum number of variables that we can show in a scatter plot is basically 2, right? Because we have only 2 dimensions. If we want, I mean, in a 2-dimensional plot. Of course, if you get a 3-dimensional plot, well, you can show 3. But there's also some way to excuse me. There's some way to include another variable inside this plot. So we want to add a third variable into this plot, and which we can do it by using a different color for these data points. For example, I'm going to look into a third variable called the number of cylinders. Okay, and it seems like we have like 3 different numbers here, either 4, 6, or 8 cylinders. And for these data points, just want to add a color. I want to give them a color based on their number of cylinders. So if they're like 4 or 6 or 8, they get different colors. And so I can see a third variable here in my scatter plot. How can I do that? Well, it's pretty easy. In ggplot, we can simply do that by going back into our ggplot code. So I'm just going to take this to the next line. What I have to do is I need to go to the body of my function, to ggplot, and inside AES, which you define the variables that you want to plot, and you want to plot them here. Now, because we're adding a third variable to this plot, which is called cylinders, I will add the cylinder here as a third variable. But we only have x and y. We don't have a z dimension in a 2-dimensional plot, right? Now, what I can do is I can define a new attribute called color, and then put the cylinder here. It was CYL, right? Yes. Okay. So this means that, okay, I have a third feature which is called cylinder, and I want to show it in the plot, but we can, I mean, I'm telling ggplot to show this variable as a color function, as a color feature inside my plot, because I don't really have a third, I don't have a z dimension, right? It's only like 2-dimensional. So you can add a new feature called color equal to cylinder. Let's run this and see what happens. All right, so nothing happened. I mean, there's a reason for this, because because I mean I just wanted to show you this. Cylinders are numbers, right? They're numerical values. Now, for the color feature that you add to ggplot here, this should be something like a category. It should be a discrete category. But cylinders are just like numerical values, right? So they should be strings. They should be like a different class for cylinder. Now, so what this means is that I should have like discrete labels for the cylinder, which means I need some strings. So for example, instead of number 4, number 6, number 4, number 8 in the cylinder, I need a discrete, let's say, string of 6, 4, and 8 in order to, I mean, come up with colors here, because that's, I mean, how ggplot understands that it can add a different color for different categories of cylinder. Now, because cylinder is numeric, we need to convert, we have to transform this into a string. And do you remember what was the function used for converting, for transforming a numerical vector to a string? Yes or not? I don't hear you. Yeah, it's as dot character, as some of you said. Now, okay, so just have to make sure that you close the parentheses. It's that simple. I mean, we're going to use as dot character of cylinder in order to make cylinder into strings. So it's going to be like some discrete categories. Now let's run this code and see what happens. Still, nothing happened. Okay. Can you guess what the problem is? Yeah, there's a, I mean, this is very cool. I mean, we just had to see this. I mean, I really didn't, I mean, I didn't reproduce this error myself right now, but let's look what the problem is. The problem is that, okay, I mean, this works. This color thing works. But the point is that after it's giving like different colors to different values of cylinders, what happens is that it's running this line of code, right? And this line of code is doing what? It's changing the color of all of the data points to green. That's why we always see them green. Now, what we have to do is we just need to remove this color feature here. So I think this was a, I mean, nice example to get into this error and to debug it. And then let's run the code. And then here we go. We got it finally. Now, what happens is that ggplot automatically assigns different colors to different cylinder numbers, right? And you can easily see like 3 clusters, which really makes sense because see, like the blue ones are the 8 cylinders. They're the heavier cars with lower MPGs. The green ones are 6 cylinders, and you can see like they have average weight and average MPG almost. And then the red ones are 4 cylinders, and they have like higher MPGs and lower weights. In other words, these are probably like compact size cars. These are like SUVs, and these are I don't know, like maybe trucks or bigger size cars. But anyway, you can see like by using this, by applying this technique, we were able to fit in 3 different variables into one scatter plot. That easy. Now, one thing that I mentioned here was I put like as dot character in order to create 3 different categories, because 4, 6, and 8 are considered as strings because I put as dot character here. You can even remove this. I mean, it will still work. Let's see what happens if I remove as dot character and keep the cylinders as numerical values. It will still give different colors to these data points, but see how it looks like. See? Because they're numbers, so it gives these numbers a range of colors. not discrete colors. I mean, as you can see. So, I mean, these colors are kind of distinguishable a little, pretty much, but not really distinguishable. Now, the reason is because cylinder, the values for cylinder are numerical values, and these values are considered as continuous, and that's why the color is also a spectra of continuous colors here. Now, if you want to put like separate colors, all you have to do is similar to what we did before this, was we add a as the character here in order to make cylinder of discrete values, so that when we run this line of code, I mean, we get the same plot that we got before, and you get like 3 separate colors from each other, because these are considered as 3 separate strings and discrete values, not continuous anymore. In the previous example, cylinder were continuous values, but here, because we changed them to strings, they're basically they're discrete values. All right, that was I think a cool exercise here, and it was a nice example to discuss this point. Now, all right, what else? Let's look into the empty cars data set and see if we can extract any other information out of this. Well, doesn't really seem so, but anyway, let's get into the next very useful plot, which is called box plots. Now, box plots are very also useful for comparing the distributions of different variables. Let's look into the empty cars. Now, for example, if I want to see for different cylinder numbers, what are the distributions of MPGs? Or in other words, I want to see, like, for the cars with different cylinder numbers, what is their average, or what is the range of their MPGs? For example, I mean, let's look into just 4 cylinders. Okay, I have one car here, I have another car here, I have a few cars here, see, with 4 cylinders, and they have MPG values. So in other words, I want to group their MPGs based on their cylinder numbers. And for every group, I want to see the range or the median of their MPGs to just have a great understanding of of what is the difference of MPGs in different cylinder for different cylinder numbers. That is one of the uses of a box plot. Okay, now so on my x-axis, I want different cylinder numbers. I want like 6. I want like 4, 6, and 8. So I only have like 3 discrete values of cylinders, and for each of them, I want to plot a box plot of MPGs in order to be able to compare the MPGs of different cylinder numbers. And this is something that is very easy to do in R, with just like one line of code. But I mean, if you want to do this in Excel or any other tools, it may be more complicated. You first have to like separate these cylinder numbers, and then like extract their MPGs, and then put them in like separate columns, and then do the plot. But here we can simply do this by using a box plot function. So the next one is a box plot. And this is how it works. Again, as similar to other plots, it starts with the ggplot function, which is the body of the function here. And again, we put the name of the data set, and then AES. What do I need for the x-axis? Well, I need an x equal to, I want to put the cylinder numbers on the x-axis, and then for y is I want to show the MPGs. So on x, I'm going to have the cylinder numbers. On y, I'm going to have the different distributions of MPGs. And then plus, instead of geom underline histogram or point or any other type of plot, I'm just going to use a box plot. That's simple. That's it. And this should work. Let's run this and see if it works or not. Do you think this is going to work? I would say no. And I'll tell you why. Well, I mean, you can see that, okay, we didn't really get what we wanted. The reason is because it's telling us that x is continuous, okay, and it's not considered as like a group. Now, the same thing, I mean, we talked about here in scatter plot in order to like get discrete colors for the cylinder. Here, for the x, we need different or discrete categories of cylinder. That's why we change it to a character using as.character, and then run the same code. And if you click on zoom, you can simply see that, okay, for different cylinders, cylinder number for 4, 6, and 8, here you have a box plot showing the range of the MPGs. And this line shows the median of the MPGs, and then this line shows the upper quartile. This one shows the lower quartile. So upper quartile means that only 25% of the data is higher than this value. Only 25% of the MPGs for the 4-cylinder cars have an MPG greater than, like, I don't know, like this is 31, for example, or 30.5 or greater. And then this is the lower quartile, so it means like only 25% of the cars have an MPG lower than this. Okay, and then this is the median. For more details, I mean, you can look into the slides, or you can go look into the box plot tutorial in ggplot. There's, I mean, so much details about like how these lines are calculated, I mean, and how these outliers are found. So for example, these two data points are considered as outliers because in this because this, for example, a car which has 8 cylinders has a very low MPG comparing to the other ones, right? So that's why it's an outlier. Or this guy here, this car here, it has a pretty higher MPG comparing to other cars with 8 cylinders. And so that's what these outliers means. The outlier means. Now, by looking at this box plot, you can simply see that, okay, the median or the mean of MPG of 4-cylinder cars are definitely greater than the 6-cylinder, and the 6-cylinder are also greater than the 8-cylinder ones. All right, and then you can play around with it. You can apply some other tricks. For example, you can, I mean, if you look at this, well, we don't, I mean, the X label really doesn't look nice. It's like as the character of cylinder, it's exactly this X value that we used here. So we can change the X label to something else, for example, number of cylinders, and then the Y. I mean, I think the Y-axis is good enough, and then add a GG title of box plots for MPGs, MPG values, or MPGs. Yeah, and then you can just run this line, run this code, and then you get this. All right, you can make them fancier by like adding some color to them. I mean, just like giving a different color for this box plot, and then a different color to this one, a different color for this one, by simply going back to the ggplot body function, and then here inside the AES, we're going to add a third feature. So we have X and Y, but we can also add a color, which the color can be based on, for example, the cylinder numbers. And I'm just going to use this as the character of cylinder, exactly the same, so that we will see some like discrete colors. Let's run this code and see what happens. And here we go. We get like 3 different colors. I mean, it's not really necessary to put different colors because, I mean, obviously this is for this box plot is for 4 cylinders. This one is for 6. This one is for 8. So we don't really need separate colors. It's just like to make it fancier. And just want to, I mean, show you like how color works, how the color feature works. Or you can change this to fill and then see what happens. If you run this, you'll like get 3 different box plots with 3 different colors filled up and filled in. Now, right, that's the use of box plot. And we also, last time we talked about, all right, we talked about jitter plots. I mean, you can look into it. You can look into the slides. It's cool. It's very similar to a box plot. I mean, it gives you like the similar information in a box plot, but the only because it's like giving you the kind of distribution, you know, in every class. But the difference is like it doesn't really consider any stats, any statistical um, values or measurements. I mean, here you have like the mean, you have the exact upper quartile, the lower quartile, and so forth, but you don't have this information here. That's one of the differences. Anyway, you can look into this for more details about box plots, and and then the other type of plot is also violin plot. So it's very similar to box plots. It's just like it shows the exact shape of distribution in every class. If I go back to my box plot here, I mean, I can just change this box plot to violin plot and see what happens. All right, and then run this code, and here we go. So you can even see the shape of the distribution of MPGs in every cylinder number, right? And simply by just changing one number. I mean, that's the beauty of R and the visualization on R. It's that simple. I mean, you don't really need to do anything fancy. You just like change the name, the word box plot into violin plot, and then here we go. Here you go. You can still customize these ggplots. I mean, you can change anything you want. For example, you can remove this legend. You can change the type of this legend. You can change the colors you want. You can, you know, you can do anything. You can remove this this gray background here. You can change the sizes of these labels. You can change the sizes of the, I mean, these ticks, this Y, for example, ticks, and also the X ones. And you can change the size, the color of this title. You can do anything you want in ggplot. It's really awesome. You can look into, I mean, the tutorials and some of the manuals for ggplot for more details if you want to make it, like if you want to customize it more, if you want to make some changes, some you know, and add some details to your plot, you can look it up, definitely. All right, now the next topic was, all right, I'm just going to skip these. I mean, this is also a heat map. It's sometimes used. You can use this code to run. You can run this code in order to produce a heat map and see how it looks like. And then the next topic was interactive plots. So it's in a library called plotly. If you go here again into the packages and then install and then type plotly, right here it is. And then install, and it's going to download and install that library for you. But oops, all right. But yeah, but I'm just going to show you how it works. Simply, I mean, you can look into Plotly yourself if you want. I've provided a link inside the slides, and which you can go through that link and see a lot of details about Plotly. Anyway, first of all, after you install this library, you need to also load it anytime you want to use it. So library of Plotly, I'm just going to load it here, run this line of code, and then here it is. It's loaded here. Now you can grab the same code that I put here, just as an example, and copy it and go back into R, paste it, and see how it works. Well, we don't need this line of code. Just remove these greater signs. Oops. And then enter. And here we go. So if you zoom in into this plot, you can see as you move your cursor on the data points, you can simply see some extra information about the data points. For example, some values or some labels for the data. And then this cool thing is that you can even zoom in into some part of your scatter plot. I'm also running out of battery. I hope we can finish soon. And then by double clicking on the plane, you will get back to the normal mode. It's going to be like zoom out. There's also some tools here you can use. But anyway, this is also very cool. It's a very useful thing. The only problem that I found with this is, I mean, this kind of plots, it's not very easy to publish. You know, if you want to send this to someone else, There's a few ways to do it. I mean, if you look into the Plotly website, like you can create an account in Plotly and then and then write some code and then upload and publish your plots onto their website and then send the link to someone if you want to. I mean, show your plots. But I mean, of course, a lot of times, I mean, you have like private data. But I mean, they claim that, like, for example, they have some sort of private or more secured accounts which you can use that no one can access or something like that. But I mean, who can trust them? I mean, that's probably something, that's a fact. But anyway, or for example, there's also a plugin in PowerPoint only for Windows machine. Unfortunately, doesn't exist for Mac, which you can download. That I mean, I couldn't find it right now. It's well, it's called, so it was a plugin for Plotly in PowerPoint. You can find it here. Probably it's here. Oh, here it is. So it's Plotly D3 something. I don't know. Yeah, here it is. So you can actually, it's a free ad. You can add this plugin to your PowerPoint account, and then and then you can simply just insert those interactive plots into PowerPoint, and you will see the same thing in PowerPoint. So for example, and you will have the same thing inside your slides, which if you move your cursor, you will see like some extra information about it. All right, I mean, I'm not really going to go through this Plotly that much. So let me just put this here. I mean, you can go through the details yourself if you like, and play around with it and see how it works. And I mean, you can look into this, for example, data set example, which is called diamonds. Just look into, like, you'll see all of these columns like carat, price, and so forth. And then you can play around with it to create your own plots. Now, for more details, you can go to their website. So Plotly in R has a very nice tutorial. If you go there, for example, I think it's this one here. Yeah, so you can get a lot of details about Plotly, how it. I mean, you see, you can like play around with them, and or you can see like these subplots here, which you can get all sort of information you want out of them. There's also something cool. I think if you click on them, on one of these legends, on one of the items in the legends, you can turn them on and off. See, like it turned this off, or you can remove this one. For example, if you click on the blue one, it will remove, and then it will add the blue plot here. Anyway, I mean, there's tons of things you can do. You can do like a 3D plot. This is like amazing. Just look at it. If you go through it, you can go through. You can zoom in and zoom out. You can turn it around. You can turn around the whole plot, and then look at it from different angles, and then you can just turn it around, and you can do a lot of cool stuff, in R. This is, I mean, one of the beauties of R, for sure. And then here is a more detailed tutorial and details and code examples for all different type of plots that you want to do in Plotly. You can do like any sort of plots you like, and you can click on them. For example, you can do box plots. I mean, this is what really amazing. I've been using this a lot. Or all sort of interactive plots. Let's look into the lab works for week 2. Here we want to use a new data set called US arrests. It's again one of those built-in data sets in R, which you can simply use. And you can go to this link for more information, which will explains all the columns, what they are, what are the column names. And here I've asked a bunch of questions which you can try to answer. Now, let's look at the first one. I mean, which state has the highest rate of murder? How about rape? In order to answer this question, we need to know what which is. Let me just go to this previous data set that we were using, empty cars, and I'll explain what is which. I mean, how to use this function in R. For example, looking into the MPG column, you can use the max function to find the maximum MPG, right? I mean, if you want to see, like, out of these numbers, which number is the highest MPG in this column, we can use the max function. If you remember, it's max of the empty cars data set. And do you remember how we can access the first column? We can either use like $MPG to access the MPG column, okay, and it's going to give us 33.9. So this is the maximum MPG in this column, in the first column, in the column of MPG. We can also write this in another way of empty cars, and instead of using $MPG, we can use the column number. If you recall this, we put a comma and then we put the column number. So this means when you leave one of these indexes black, it means all of them. So if you leave the first index here black, it means all of the rows. And then this one means column number 1. Now empty cars of blank comma 1 means all of the rows of column 1. And this should also give us the same value, 33.9. Now, or you can do the same thing for minimum, for average, you know, for mean, and so forth. For example, you can change this to mean, and it will give you the average MPG of all of the cards. It's like 20.09, and so forth. Now, another question is, well, okay, this is the maximum MPG, but which row or which of these cars have the maximum MPG? That's the next question. There's a simple function called which you can use. So it's like which, you say which.max has the maximum MPG. So empty cars of MPG. This will give you the row number. If you run this line of code, you get the row number. So row number 20, if you go to empty cars and you find like row number 20, whatever it is, will have the maximum MPG of 33.9. Okay. Now, this is the index. How can I find the car? Let's access the car number because we don't really see any indexes here. We can use this index here. So I'm going to call this the index of the car. Okay, I'm going to call it end or index of the car. Now, in order to access the car, this is, if you recall, we use row names to access these names here, and column names to access these column names. Now we need the row name because we want to look up which car is it, which car here has index 20. It's for example, row names of the empty cars. This is gonna, if you run this, it will print out all of the row names, all of the cars for us. But we want to access this index only. We want to see like what is the 20th car here. And so you can simply put the index inside a bracket, and if you run this, it will, oops, I'm sorry, index was not assigned, so run this line of code and then this one, and it will give you Toyota Corolla. And that makes sense. Toyota Corolla should definitely have the highest MPG. And all right, so one more time, row names of empty cars will return all of these row names in here at this part of the data set. And when you put the index inside a bracket, it will pull out only that index for you. And by running this line of code, we figured out that, okay, the maximum MPG of the empty cars is, and here's the index we found, and then we put the index here to pull out the name of the car in empty cars, which has the highest MPG. This is how you can do this. You can access this. You can do the same thing for minimum. For example, let's see which car has the minimum MPG. You can just put min here, right? And then run this line of code, and then this one, and it's a Cadillac Fleetwood has the lowest MPG. All right, guys. You could probably guess. Now, let's see the use of which. Which is also used for in a more general purpose. It's not just for minimum and maximum. This which.min is a simple function used for only minimum and maximum. But for example, in more general, if you want to look up for all of the MPGs that are greater than 30, okay? Okay, so you can say that, okay, which MPG, well, so empty cars, MPG, so which of the MPGs in the column MPG of empty cars are greater than 30? If I run this line of code, see what happens. It returns the indexes of these rows which have an MPG of greater than 30. See, that's a cool query, right? You can easily pull out some information you want out of the data. Which empty cars of MPG is greater than 30? That's simple. So as you saw, when you print this out, this will give you the indexes of, or the row numbers of the dataset empty cars which have an MPG greater than 30. How can we, let's do the same thing we did here. I mean, how can we access the name of the cars which have an MPG greater than 30? Well, you can, I'm just going to copy this, put it here, and then assign this one to index 1, for example, just a different variable, and then put index 1 here. This should also give me the name of the cars that have an MPG greater than 30. See, I'm going to run it, and here we go. These are the 3 cars that have an MPG greater than 30. That's how you can get some, I'm sorry, 4 cars, right? We had 4 indexes here, and we have 4 cars here. These are the 4 cars which have an MPG greater than 30. You can do the same thing for anyone else. I mean, anything else. We can also redo this which.min by using only which. For example, we can say that which empty cars MPG. So I just want to avoid using which.min, okay? Just want to use which. Which empty cars of MPG is equal to, we put 2 equal signs, because this is, if you put just 1 equal sign, it means like an assignment. So you're assigning something to empty cars $MPG. But here we just want to check, this is an if statement. We would just want to check if or which empty cars of MPG is equal to the maximum of empty cars MPG. This should also give me index 20, if you recall. I mean, this one was giving me index 20, and this is the same thing. I just did it without using which.min. I'm just using which. If I run this, it will give me 20, the same thing. And you can do this for also minimum as well, and so forth. Anyway, which is a very useful function in order to pull out and apply some queries into the data set and find out, some of the rows and columns that you're more interested in, and to pull out some data. So you need this which function in order to find the solutions. Here you find the highest rate of murder, which state has the highest rate of murder, which state has the lowest rate of murder. Again, in the US arrest data set, it's not empty cars anymore. What is the average rate of rape and murder? You can do it easily, and then draw a histogram, and then draw a scatter plot here to see if there's any correlation between these 2 variables, and then exclude the 3 states from the data set which have the highest rate of rapes. So what you can do here is you can first find the first state that has the highest rate of rapes, find the index for that state, and then remove that state from the data set. You can copy it into another variable, another data set, and then again find the highest rate of rapes, find the state that has the highest rate of rapes in that second data set, exclude it again, and then copy it into another data set, and then again find the highest one, and that way you can easily exclude the 3 states that have the highest rates of rape. All right, the next question is again very similar. It's just a different data set here, and you can look into the details of this data set at this link, and then simply answer these questions. All right, guys, I hope you have a great rest of your weekend. If you have any more questions, please feel free to send me an email anytime. All right, guys, take care. Bye-bye.